Here are the answers to problem set number 1, which is chapter 2. And in the first question, the helicopter blade is spinning at 100 revolutions per minute. Its tip is 5 meters from the center. You're asked to find the speed. So it's 5 meters, and average speed is total distance by total time. And in this case, you know that the distance made in one rotation is 2 pi times the radius, which is the circumference. And therefore the distance in 100 revolutions would be 100 times the circumference. So the time is in minutes, it's 60 seconds, and therefore the average speed is the total distance 100 times 2 pi times 5 by 60, 52.4 meters per second. In the B part, you're asked to find the average velocity over one revolution. And the average velocity is displacement over time. Since the displacement is 0, since it comes back to the starting point after every rotation, the displacement is 0, therefore the average velocity is 0. Question 2. The student drove to the university, and the distance was 12 kilometers. The trip took 18 minutes. We got to find the average speed. Again, the average speed is distance by time here. That's kilometers in meters. That's 12,000. Divided by 18 minutes has to be converted into seconds. So that's 18 times 60. So now you have it in meter per second. And second part of the question says that the straight line distance from our home to the university is only 10.3 kilometers in a direction 25 degrees south of east. What's the average velocity? Now the displacement is 10.3, again into meter. That's why you have 10 to the 3. Time in seconds. So you get 9.54 meter per second, 25 degrees east of south. And the C part says if she returned home by the same path 7 hours and 30 minutes after she left, what was her average speed and velocity? So now to find the average speed, you got to take the total distance. She came back by the same path, so the distance is 10.3 multiplied by 2. That's in kilometers divided by. So now change it, and you get 0.046 meter per second. And I forgot to multiply, to change kilometer into meters. So I had to have 10 to the 3 here, which is 1,000. That would make this 1, 2, 3, 46. Okay. Well, and that was 7.5 hours, 30 minutes. So again, I had to multiply that with a 60 to change it into seconds. And then my answer changes. So let me calculate that. Now you get it as 6 divided by 60. So when you do all that, you get 0.7629 meter per second. Okay. And then you're asked to find the average velocity. And you know that the displacement is 0. Therefore the average velocity is 0. Oh, I have to remember now. It's 0.76 meter per second. I hope you can make out that. And question 3. The initial velocity is 0. The acceleration is 1.4 meter per second squared. And you got to find the time for her to reach a velocity of 2 meters per second. The equation is acceleration is Vf minus V0 divided by T. Now rearrange that and you get the answer as 2 by 1.4, which is 1.43 seconds. In the second part, she then brakes to a stop in 0.800 seconds. So now her initial velocity is 2 meters per second. Her final velocity is 0. The time, you got to find the acceleration. Again, use the same formula. Obviously, you're going to get a negative because she's slowing down. You get negative 0.25 meters per second squared. Actually, negative 2.5 meters per second squared. In the fourth question, the initial velocity of the bullet is 0. The acceleration is given really high. The time is small. You got to find the final velocity. Again, use the formula for acceleration. Cross multiply that, rearrange it to make the final velocity the subject. And I'm showing you how we get that. And then substitute the numbers. You get 502.2 meters per second, which is of course a large velocity as expected for a bullet. Oh, is that the fifth one at the end of a race? Okay, so I go back to that, and then the fifth one. It's the end of a race. She goes from 9 meters per second. That's her initial velocity. And because she is decelerating, A is negative. Time 5 seconds, and you have to find her final velocity. And first you have to find how far she travels, so that's delta x. Now, this is the equation that you use. Plug in the numbers carefully. Remember that A is negative. Okay, 20 meters. So B part, you got to find her final velocity using this equation. Initial is 9. Remember, A is negative. Time is 5 seconds. You get 9 minus 10, which is negative 1, which is a negative velocity. And C part says evaluate the result. Well, this does not make any sense because when the velocity is negative, that means she's going in the opposite direction. And obviously a runner does not do that. She decelerates to a stop. In the sixth question, the initial velocity is 0. Final is 65 meters per second. Displacement is 0.250 meter. And you got to find the time. Now here the equation is average velocity multiplied by time gives displacement. And when you rearrange it, you get the time. .69 times 10 to the negative 3 seconds. And now we have to find the acceleration. So A is the subject, so obviously this is the equation. One of the equations. You could have done it another way. Okay. So you get 8450 meter per second squared. That's the acceleration. And number 7, got to find the displacement and velocity at different times. And I'm just going to do it for maybe 1 or 2. This rock is thrown straight down with an initial velocity of 14, so V0 is 14, A is 9.8, it's freely falling object, and time 0.5. So you find the displacement. .225 meter, and then find the final velocity after 0.5 seconds. .9 meter per second. And I'm doing it for one more time, maybe 1 second. Same equations, only quantity that changes is the time. .9 meter. And to find the final velocity, of course it's going to be larger than the first one. Yes, it's 23.8 meter per second after 1 second. So you can complete this problem the same way for the other times mentioned. In the 8th question, the rock is thrown straight up from a cliff. It takes 2.35 seconds to go up, and then for it to come down, you got to find the height of the cliff. Alright, that's the path taken. Initial velocity is 8. Initially it's going up, so it's decelerating. We only take what happens initially, so it's negative 9.8 meter per second squared. The time is given. Got to find the displacement. And the displacement is given by this equation. You get negative 8.26 meters. Okay, in the B part. Now remember that it's negative 8.26 because when it's first going up, you take that as positive, and coming down is negative. So that means actually what you get is negative, let me use another column. Okay, what do you get as negative 8.26 is this. So you're getting the height of the cliff, and that is, it's negative because it's coming down. The initial direction is taken as positive. Okay. In the second part, it's thrown straight down with the same initial velocity. This time A is positive instead of being negative. And you have to find the time now. Now you know the displacement is 8.26. Remember, it's being thrown down. You take the initial direction as positive, so it's 8.26 meters positive. Use the same equation. And you set up a quadratic equation. Rearrange the terms. And for a quadratic equation, the solution is given by minus b plus minus square root b squared minus 4ac by 2a. And of course, you have to know that a is this quantity, b is this, and c is this, with their signs included. Okay. So when you know that, you can easily solve this. Remember that you got to consider their signs too. That's why it's, see, C is negative. Notice that. Oh, that's. So you get 0.72 seconds. 0.72 seconds. 9th one. You have to find the distance traveled during the first second. Okay. its initial velocity is 0 because it's dropped in 1 second, and a is 9.8 because it's accelerating. Use this equation. The first term just becomes 0, so it vanishes at 4.9 meter. And then you have to find the final velocity at which the object hits the ground. So it is 9.8 meter per second. In the C part, you're asked to find the distance traveled during the last second of its motion. Okay, so now you'll have to find out, which means that in part B, I think I forgot to switch on the recording. Now I switched it on. Now to understand question 10, you need to have your graph right before you and make sure that you take the first slope from the displacement time graph, and if you look at it carefully, at 15 seconds the displacement is 1100, at 25 seconds it's 2250. So you take the difference in the displacements divided by the difference in the corresponding times. And to find the acceleration, you do the same from the velocity time graph. And once again, looking at the graph, you see that at 15 seconds the velocity is 100, and at 25 seconds the velocity is 150. So that's how you get it as 5 meter per second squared. Well, I hope it's okay, and I hope you understand. If you have any questions, you can always communicate with me and try to understand before the exam. Thank you and good luck.